When we're looking at inverses, we've learned that in order to find the inverses of points, that you switch x and y. To find the inverse of a table, you switch the x and the y. To find the inverse of the graph, you switch the x and the y, or you could reflect it across the y equals x line. Okay? Your y equals x line will make it so that it is switching the x and the y. Okay? Now, the way that we represent our inverses is with this thing right here. Okay? The way that we verbally say that is f inverse of x. So we don't say f to the -1 of x. We always verbally say f inverse of x. Okay? Now, in previous years, you had your vertical line test. Your vertical line test was a way for you to determine if the relation was a function. So if any vertical line touched the graph more than once, then it was not a function. Now we've looked at the horizontal line test. The horizontal line test tells you if any horizontal line crosses the function, then its inverse is not a function. So it's very important that you realize the vertical line test tells you about the original, the horizontal line test tells you about the inverse. Now, when it's both a function and its inverse is a function, we call that thing one-to-one function. Okay? Now the part that we haven't looked at is this next part. So this next part, we have been switching x's and y's on points, on graphs, on tables, and that same thing happens with your domain and range. Now remember, we just reviewed, your domain is your x values. Your range is your y values. So your domain, you're looking how far left and right your graph goes. Your range is how far up and down your graph goes. Okay, so domain is with x's, range is with y's. So if on inverses we switch the x and the y, that means that your domain and ranges are going to switch of your original functions and your inverses, because you're switching your x's and your y's, or you're switching your input and your output, right? So let's go to these examples. Determine if it's one-to-one and state the domain and range of the original and the inverse. Okay, so here, if we check our lines, this fails the vertical. It also fails the horizontal. So this is for sure not one-to-one. We can still say what the domain of the original is and the range of the original. And then we can say what the inverse is for the domain and range. So if we look here at our domain, on our domain for our x's, we're going this far left and this far right, and we're spanning everything in between there, right? So we're going from -2 I'm going to call that -2.5 to 3 I'm going to call that 3.2. So we're going from -3.5 to, 2.5 to 3.12. 3.2. I think is what I had said. And notice I've got brackets because it's touching at this x value and touching at this x value. Well, if we look at our y values span from here and goes all the way up to here. So I'm going to call that, I don't know, -1.4. Estimating is fine in this situation. And then 4.5. Right? And again, I have brackets because it's touching at this y value and at this y value. Right? So if we want the domain and range of the inverse, what happens is they swap spots. So the domain goes to the range and the range goes to the domain. So even though I don't have the inverse drawn, I know what the domain and range is. So my range of the original goes to the domain of the inverse. So -1.4 to 4.5. And the domain of the original goes to the inverse range. So from -2.5 to 3.2. And I need to bracket this, sorry. Okay. So if we look at our next one, right, hopefully you recognize this as an exponential graph. If you don't, maybe that will help you recollect that I said that. So it crosses, any vertical line crosses once. Now your horizontal line, it may look like this is hitting it multiple times, but if you remember about your exponential graphs, it's going up just a teeny bit each time, right? So it really only touches it just once here. So it passes both. So because it passes both, we know that this is one-to-one. So if we look at our domain and range for the original, and then for the inverse, okay, our domain on the original, we're going all the way left. We're going all the way right. As it's going up, it's going forever to the right. So our domain is negative infinity to infinity. Or you could also write all real numbers. Our range, notice here, this is as low as we go, and then it keeps going up for forever. So if you remember about your exponentials, it just gets closer and closer and closer, but it doesn't actually ever reach this value. So it's going to reach or be really close to -6, but not actually reach it. So I'm going to do parenthesis -6 and then all the way up. So that means we can find the domain and range of our inverse. So remember, we switch x and y for all of our inverses. So my domain goes to the range of the inverse. So our range of the inverse is negative infinity to infinity. And then the range of the original goes to the domain of the inverse. So from -6 to infinity. So even though I don't have it drawn, I can know what my domain and range is from the original graph by switching, or of the inverse graph by switching the domain and range of the original one. Okay? Let's take a look at the next one. Okay, this passes the vertical line test, passes the horizontal line test. Hopefully you recognize this as a polynomial. So this is just, it looks really close, but again, it's just going up just a little bit each time there, right? And a little bit each time. So it passes the horizontal line test, so it passes both. So when it passes both, we call it 1-to-1. You can spell out 1-to-1 as well, like I did up here, but you can also just use the number 1 and then to 1. So our domain of the original, we are going all the way left as we go down, and we're going all the way right as we go up. So our domain is negative infinity to infinity. Or you could write all real numbers. Our range, we're going all the way down and all the way up. So our range is negative infinity to infinity. Or again, all real numbers. So that makes it really easy for our inverse. Our domain and range are exactly the same, negative infinity to infinity and negative infinity to infinity. Remember with your infinities that you always do parentheses. Okay, let's take a look at this next one. So if we do vertical line test, passes. Horizontal line test, it fails. So it's not 1-to-1, okay, because the inverse is not a function. But if we look at the original, or domain, we're going all the way left and all the way right as it's going up. So our domain is negative infinity to infinity. Our range, this is the lowest that we go. We don't have any graph below here. So our low is this number at 4, and then we go up from there. So we're starting at 4, it touches at 4, so it's a bracket, and then it goes up for forever, so 4 to infinity. Okay? Which means that for the inverse, we just switch our domain and range. Right? So our domain is the range from the original, so bracket 4 to infinity, and our range is from the domain, so negative infinity to infinity. Okay, let's try one more. Okay, so if we look at this one, this is a rational graph that we haven't done a ton of. We saw that it's not a polynomial when we were looking at our polynomials, but this is kind of like your exponential graph in that this is going slightly over each time, or this is going slightly down each time. So even though it looks like it may touch it multiple times, it only touches it once. And then the horizontal, it passes the horizontal, so it passes both. So if it passes both, then it's 1-to-1. So if we're going to look at our domain, this one is a little bit more complicated. This is going all the way left, and this is going all the way down, but it's only, there's this gap right here, right? So I get really, really close to the 0, but I don't ever touch the 0. And then I've got this where it comes really close on the right side of 0, but it doesn't ever touch it. So the way that I'm going to write that is we go from negative infinity to 0, but I'm not touching it. But then I pick up on the other side of 0, sorry, not infinity, of 0, and then I go all the way to the right. We could also write this as x cannot be 0. That would be another way that we could look at that. Okay. Our range of the original is we're going all the way down, go all the way up to here. We're just getting really close to this value of 2. I'm just coming on the underside of 2, but I won't ever touch it. But then I'm coming on the upper side of 2 and then going up for forever. So it's that same kind of thing where we're going to go from negative infinity to 2, from 2 to infinity. So that's for our original. Well, now I want for the inverse. So again, the domain of the original goes to the range of the inverse, and the range of the inverse goes to the domain. So that means our domain of the inverse is going to be negative infinity to 2, and from 2 to infinity. And the range is going to be negative infinity to 0, and 0 to infinity. So that's how you find the domain and range for your inverses.